Hello, hello students. Today I am going to teach you ninth math. My name is Ashok Rajput. Today I will tell you about the polynomials. First we explain applications. It means what are the applications of polynomials in our real life. They are, we can say, what are the uses of applications in our real life. Then we will explain theory. So you will be attentive and see it very carefully and try to understood. If you have any problem, then you can always ask me. So I am going to explain it. What are applications of real life in our daily life? Applications as you are seeing here. Next, polynomials in real life to find the path of throwing ball. The path of throwing ball is parabolic. What is parabolic? As you are seeing in this picture, it is the path of parabolic. When you throw any wall or any piece of solid metal, then you always see it runs such types of paths. So when we draw a graph of quadratic polynomial, quadratic means if its power is 2, the graph is parabolic. Such path is called a parabolic path. As it is written here, ax square plus bx plus c equal to 0 is a quadratic polynomial. If anywhere you find such type of polynomial, then you can say it is the quadratic polynomial. Then next, to find the distance and speed after some time of moving by car, bus, train or any vehicles. So you can find with the help of quadratic polynomial to find the acceleration when we applied force on the body. This formula you have studied in physics also. F equal to ma. F is force, m is mass of the body, and a is acceleration. From here, if you applied force on any certain body, then you can find the acceleration from here. Next, calculating the speed and height of freely falling body under gravity. As you will take help with these types of quadratic polynomials, v square equal to u square plus 2gh and h equal to ut plus of gt square. Here v is final velocity, u is initial velocity, g is gravity and h is height. The same here, h is height, u is initial velocity, t is time, g is gravity and t is time taken. So this way polynomials are very useful in our real life in many ways. These are simple uses. In many ways it is very useful in real life. In many ways it helps to in production also, in other ways also. Now we are going to explain on theory. Theory is the base of this chapter, or in each chapter theory is the base. So first we define constant, a symbol having a fixed numerical value is called a constant. What is fixed means unchanged, which never can be changed. That value is fixed numerical value. As we see 1, 2, 3, root 3, root 6, root 2, pi, add extra. After that, we are going to define variables as variables, variable. This means which term have, have the ability of vary. It means its value may be changed. As we have defined here, a symbol which have ability of varying or which may be assigned ability of varying or which may be assigned different numerical value. It means we can put different values at the place of the symbol. The values is known as a variable. Examples 7x plus 4y. Here x and y are variables and 7 and 4 are constants. As we know already about the constants as numbers are constant and alphabets are variables. Algebraic expression combination of constant and variables. Combination of constant and variables in which it means should be constant also and variables also and connected by some of or all of the operations. Operations means in mathematics we will calculate only four things: plus, minus, division, and multiplication. These are four operations, and if these applies with the constant and variables is known as an algebraic expression. As we have written here, example 1, 5x square minus 9x plus 4. And the second, y raised to the power 4 minus 64. These are algebraic expressions. Then terms of an algebraic expression. How we decide the terms? How many terms in the given expression? The several part of an algebraic expression separated by plus or minus. Here terms are separated plus by the sign of plus or minus are called the terms of the expressions. As we have used here both signs, see in the example 5x square plus 3x minus 8. In this expression, terms are 3. We can count here 1, then plus, second, then minus, then third. Here are 3 terms. So it is very simple, but we should be attentive. If we are attentive and we have interest in study and want to learn it, then these things are very simple and easy also. Definitions as standard form of polynomials. How we define the what is the standard form. The definition of standard form: a polynomial in X expressed either in ascending order of powers or in descending order of powers is said to be in standard form. First we write the polynomial, then we arrange the powers in ascending order or in descending order. If we have arranged powers in any system, as here are two systems, ascending and descending. Mostly we arrange in descending form, but we can arrange in ascending also. As examples, first one 3x square minus 8x plus 9, and next one is 4x square minus 9x plus 5. Here we are seeing in first term power is 2, second term power is 1, and at the end power is 0. Why it is 0? Because if we put the power of any variable or any constant 0, then its value will be 1. So here is its power is 0 because x is not here because that value is 1. Now we are going to explain the next polynomials. About the polynomials, first we have defined the what is polynomial, what are expressions. Now we want to know how many types are they, and if we understood it will be easy for me. Then a term, a polynomial in X is an algebraic expression containing only non-negative integral parts. Non-negative integral parts of X when arranged in ascending or descending order. It is compulsory. First we arrange the parts in ascending or descending order. Then it is as we have written here general polynomial a naught a1x a2x square a3x cube plus here plus and plus an x raised to the power n where x is a variable and a is constant. Terms based classification of polynomials. Terms based, it means how many terms are there. Classification of polynomials. So there are five types of polynomials. First one, monomial. It means if one term, then it is monomial. If there are two terms, then it is binomial. If there are three terms, then there are trinomials. If they are zero polynomials and then constant, such way we can define in the next degree based classification of polynomials. There are four types of polynomials. Linear polynomial. If its degree is 1, then it is linear. Then quadratic polynomial. If its degree is 2, cubic polynomial if its degree is 3, biquadratic polynomial if its degree is 4. And we will define also just now. So have you understood? It means five types of polynomials based on terms and four types of polynomials based on degree. So we will define these also. Definitions of polynomials based on terms. First we define the polynomials based on terms. Monomials. A polynomial having only one term is called monomial. It is very simple. If it's here are only one term, here is only one term, then it is monomial. Examples 3x raised to the power 4, x cube, 4x, at extra you can write so many. A binomial. A polynomial having two terms is called binomial. Examples are x square minus 7, 5x square plus x square plus 7 at extra. It means there are so many. Trinomials. A polynomial having three terms is called a trinomial. Examples are x square plus 2x plus 5, x cube plus x plus 7, x cube plus 3x square plus 5 at extra. Next, zero polynomial. A zero polynomial has no degree. First we try to understand. A zero polynomial has no degree. It means its degree is zero. Our coefficient of each term is zero. As we have written here, 0 into x raised to the power 4. If we multiply, we will get 0. It means there is no degree. But we are saying here there is degree is 4. Here we are saying degree is 2. Here we are seeing degree is 1, but if we multiply it by 0, it will be 0. It means it has not any degree. So these are examples of zero polynomials. The next, the constant polynomial. A polynomial having only one term equal to a real number is called a constant polynomial. Real numbers. We will under root 3 dot dot up to infinite you can write they are unlimited. Have you understood? There are five types of polynomials based on terms. There are five polynomials based on terms and monomial, binomial, trinomial, zero polynomial, and constant polynomial. Now we're going to define the next the polynomials based on degree. Polynomials based on degree. How many types of polynomials based on degree and what are they? Linear polynomial. A polynomial of degree 1 is called a linear polynomial. As we are seeing here in the example 3x minus 1, here power is 1, 5x plus 1, here power is 1, root 2x plus 5, here power is 1, at extra. Then we define the quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. In the examples as we are seeing, x square plus x plus 1, x square plus 1 at extra. We have written here two examples, so you can write so many and see in your exercises so many quadratic polynomials. Cubic polynomials. A polynomial of degree 3 is called a cubic polynomial. As we see in the example, 2x raised to the power 3 at 2x cube minus 5x square plus 3x cube plus 1 at extra. Biquadratic polynomial. A polynomial of degree 4 is called biquadratic polynomial. Biquadratic means if its power is 4. If its power is 4, then it is biquadratic polynomial. As we are seeing in the example, x raised to the power 4 plus 1 in the first, in the next, 3x raised to the power 4 plus 5x square at extra. This way we have defined the linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial. These are so simple, these are not difficult. So you will practice and see these types of definitions in many times. Now we are going to explain the next the value of polynomials. First we define the value of polynomial px at x equal to alpha is obtained by putting x equal to alpha in px and it is denoted by p alpha. First we write the px, then we put at the place of x a alpha and after solving which value we get that one will be p alpha. For example, if px is 3x square minus 5x plus 6, then we want to find the p2. Here we have px equal to 3x square minus 5x plus 6, then p2 will be 3 into 2 square minus 5 into 2 and x plus 6. Here we are seeing at the place of x we have written here to Here also we have written 2. Here square of 2 is 4. So we will multiply it. 3 into 4 equal to 12. Now it is 5 into 2, 10. It is 6. So after that we will arrange the terms. Here we have written 12 plus 6 minus 10. 12 plus 6 equal to 18. 18 minus 10 equal to 8. Therefore, P2 equal to 8. Such way we can find the value of the polynomial. So such types of question you will practice and other sums also in the book. So this way you can find the value of the polynomial. It is the method. It is very easy for you. It is not difficult. This way you can find this. Now we are going to explain the zeros of polynomials. First we define it. Let Px be a polynomial. If P alpha equal to 0, then we say that alpha is a 0 of polynomial. If P alpha is not equal to 0, then alpha is not 0 of the given polynomial. First we, as it is given in the example, find a 0 of polynomial Px equal to x minus 3. First we put it equal to 0 as we have Px equal to 0, x minus 3 equal to 0. We have transposed here 3 to the right side. So x equal to 3. Therefore 3 is 0 of polynomial Px of x minus 3. Important observations. These are very helpful. So first we read it very carefully and try to understand. And a constant polynomial does not have any zero. Because its degree is zero, so it has not any zero. Every linear polynomial has one and only one zero because its degree is 1. If its degree is 1, so it is linear, therefore it has only one zero. A polynomial can have repeated zeros also, as after solving we are getting in the form x minus 2 whole square or x plus 2 whole square, then we will get the repeated zeros. So these 3 points are very important and helpful. How we get the repeated or 1 or not any zero. So now we are going to the next Euclid's division algorithm. Definition: every positive number that can be divided by another positive number leaving as a remainder can be written as. Here we are seeing, as we have defined, every positive number. If we have taken a positive number and divided by another positive number and leaving as a remainder, then we can write this way: A equal to BQ plus R, where R is smaller than divisor and greater or equal to 0. It is the compulsory. If remainder is not equal to, not smaller than divisor, then it is incorrect. So where we are saying R is remainder, B is divisor, A is dividend, Q is quotient. Examples: divide 245 by 15. First we divide it, then we apply this algorithm. First we divide 245 by 15. 15 ones are 15. Then we have subtracted here 24 minus 15 or 14 minus 5 equal to, here will remain 9. 1 minus 1 0. We will take from here 5. Then it will be 95. Then 15, 15 6 are 90. After subtracting, we will get the 5 minus 0, 5, 9 minus 9, 0. So 5 is remainder, 200, 15 is dividend, 16 is quotient. and 15 is divisor as we have mentioned here. You are seeing also. Then we will use the algorithm A equal to BQ plus R and justify if our steps are correct. Then 245 is A, 15 is divisor and 16 is quotient, 5 is remainder. So we multiply 15 into 16. After multiplication we will get here 240, then 240 plus 5 equal to 245. Now we are seeing here 245 equal to 245 or left hand side equal to right hand side. So it is correct. It follows the algorithm. So our working is correct. This way we will use the Euclid's division algorithm and find the quotient and remainder and check it also. Now we are going to the next, the remainder theorem. It is very important theorem in for factorization also and finding the remainder also. Let Tx be a polynomial of degree 1 or more and let alpha be any real number if Px is divided by x minus alpha, then remainder is P alpha. First we take x minus alpha as dividing divisor and then find the value of x and we find the value of PA at the PA of polynomial. Let Px be a polynomial of degree 1 or more and let alpha be any real number. When Px is divided by x minus alpha, then the quotient is Qx and remainder is Rx. Now we are going to check it, but here we will put only value as we work in the questions. We have Px equal to x minus alpha, it is divisor, then Qx plus remainder. We will write this way, but here are not real values, so we will write only where degree degree of our x is smaller than degree x minus alpha equal to 1. There, since degree of x minus alpha equal to 1, but degree of px is smaller than 1, so rx equal to 1, rx is equal to 0. It means it is smaller than 1. So degree is 0. If degree is 0, then it is a constant. Therefore, Rx is constant. The Px equal to x minus alpha plus into Qx, sorry, plus Rx, putting x equal to alpha on both sides in equation 1. We get P alpha equal to alpha minus alpha 0 and Qx plus R. We are getting here when we multiply it will be 0. So equal to R. P alpha equal to only R. So we have written here R equal to P alpha. Thus, when Px is divided by x minus alpha, the remainder is P alpha. It is the remainder theorem. When Px is divided by x minus alpha, then remainder is P alpha. Or we can say the value of a polynomial at alpha is the remainder. Now we are going to the next. Thank you for watching.